for several large companies here, contracts in the last several years. And this talk has kind of come from some of the lessons we learned from that type of thing. We've got one of my big contracts now is for a company that's in the medical industry that builds the devices for rapid testing for flu and COVID and things like that. And we ended up had just happened to in 2019 started to do a rebuild of their backend system to handle all of their data coming through from those tests and from those devices. And we went live with it at the very beginning of February of 2020. And when we went live, the system we replaced it with was they were currently running it was about 500,000 test results a year is what they were processing. And the plan was that we had to build a system that could scale, that would handle up to, I feel like they felt in a 10-year period, they would be between 1.5 to 2 million records in a year that they would have to process. So enter March of 2020, a month later, when everything kind of turned on its head. By the September, October, November timeframe of that year, especially once they started rolling out their COVID tests, but just even with the influx of the flu testing and everything was going on, we were processing over 1 million records in a week, and it with our peaks close to about 750,000 of records in an hour. I think some of our peaks. So the solutions the things that we found really kind of drove us talking a lot more about APIs and the how to scale them. A lot of that kind of falls into Azure, like some of the Azure architectures, which I'll touch on later in this talk if I have time at the end of this. But I want to kind of just start it off with kind of breaking it up into 3 parts. First, we're going to just talk about, before all this, we'll talk about building .NET 9 APIs and just some of the newer things that you've seen over the last couple of versions. In case you haven't been using them, then we'll look into scaling these APIs or securing them, then scaling, and then we'll talk a little bit at the end about architecture, some of the architecture decisions you can make with just inside an ASP.NET API in of itself, or looking at Azure and kind of more of an event-driven architecture. So if we get time, I'll touch on that. We'll just see how quickly we move through some of this stuff. So just to kind of get started, some of the best practices and some of the things that you're seeing in Azure these days. The first is AOT. I think in .NET 8 is they implemented the AOT APIs or
AOT?
Ahead of time compilation. So since in .NET, most of your stuff, it's compile time, or it's on demand, kind of generating at the very beginning of it, which means you do all your linking and all that happens at that point. Ahead of time compilation basically creates just a nice single compact piece that you can deploy. Some of the benefits of it is it's much smaller footprint. Everything is a very small compilation. The startup times are amazing. And it's definitely something to look at if you are dealing with very small implementations, especially if you do any type of work on small devices, any type of IoT type devices and things like that. It's perfect for that. It has some fallbacks to it, and the biggest one is it doesn't support the entire .NET SDK, so there are some limitations. Most of what it doesn't support is around reflection, since it's all done beforehand. So you lose a lot, and there's a lot of things that you can't do that just becomes a pain. And I'll show you an example of it here in a little bit. We'll kind of, instead, to keep us from kind of jumping back and forth constantly from code to slides, I'll group some of these things, but we'll take a look at it. The Benefit for most people is it's not worth the hassle. You're not going to take an existing API and do a migration to AOT very easily. You will find one problem after another. But it is there, and especially, as I said, especially if you deal with um, devices that have small memory footprints, small processors. We actually looked at this and have implemented this on some of the embedded devices that the company that I was talking about, for some of their devices um, that go out to the doctor's office and such. They are actually running an AOT API, compiled APIs. It met the requirements we needed for that device, and so it works very well. I mean, it gives us a way to reach out to devices and to do some updates and things like that. Minimal APIs
Hey,
showed up.
Tony, real
Yes.
question. What's an example of a device that you would deploy this to?
IoT devices are kind of really a good spot for that. As I said, so we deploy this to um, the company Quidel that I work for, contract with. They build out the devices that do the rapid testing. So you go in, you get swabbed in the doctor's office, and they put it on a slide or whatever, and it or a little sheet, takes a picture of it, and it processes that. That is using, it's basically it's just a small little microprocessor that's running on that, and we needed a web service on it to be able to push updates. So we have a small API there that opens up that allows us to securely communicate with all the devices once they've kind of registered and we know they're there. It allows us to push software updates and a little bit more larger scale things than we could through the IoT hub, because they're actually all connected to the IoT hub as well. However,
Mm.
there's only so much data you can really push through. And there's certain things that we needed for some security reasons and such have there. So we have a small footprint there that's basically a kind of a command and control type of API that allows us to do some low level stuff on the devices. And that's what we're using that for. You've got I've seen it on other small IoT devices that want to be able to allow people to connect, get statuses. I've seen somebody who's done a has a sprinkler system in their yard that they've
Oh,
connected with an
cool.
IoT device, and they played with several different ways. But one of the things they've done is it hosts a web server. Their main controller hosts a web server, so he can connect to it quickly and see the status of how much water has been used, what the current saturation, with the humidity. He's got a bunch of devices that are all connected to it. So
You know what
that's
hardware that's running on? Because it has to run the .NET framework. I mean, not framework, but like the runtime, right?
yes. I believe his is running on an Arduino.
Oh,
That's
really? You can
Yep,
run .NET on an Arduino?
on some of them, not on
Oh,
all of them, but some of them you can.
okay. What about the medical device? Do you know? I'm just curious.
I do not remember what the process on that is. That has been about 3 years ago since I've done much with that. So, or 2 years ago, I guess.
All right.
But it is a small device. Most of the operating system on it is actually written in C, or most of the code for it, but we kind of extended it out. At a version of it, the device would actually support .NET, the runtime, and so we've been kind of migrating some of the stuff over from that. So the earlier versions were too small and didn't have the memory requirements to be able to handle it. So so for minimum APIs, they showed up in .NET 6, I believe. If you have not looked at using minimal APIs, there's a lot of benefits to it. And I'll show you an example of it again. They're code-based endpoint definitions. So instead of having your controllers and doing a controller-based, it just allows you to define your endpoints quickly in code. All the things that you can do inside a controller, whether it's authorizations, defining your names, all the attributes and such you can add. You can handle that in the MMO APIs. Overall, they're better performant. They require behind the scenes, they require a lot less code and a lot less libraries to be linked into it. So you'll, for the most part, will just see better performance, even if the code inside the endpoint is the same. They are generally, once you get the hang of them, they're faster to build, they're easier to maintain, and it gives you some flexibility, which is kind of cool. We've played around with some different things, kind of config based startups of our applications, so that if, depending on the environment we're in, we might open up additional endpoints, and we can do that in the program.cs file. And when we're starting the system up, and just determine which endpoints we want to use, or which security permissions we want to use on certain endpoints and things like that. It gives us a little bit more flexibility. And as I said, as long as you don't do the thing that a lot of people start off doing in the hello world, which is taking and building all your endpoints in your program file .cs file, to where it's all just a massive list of things. As long as you actually will go through and break it up with extensions and such, it works really well. When you create an API, you have some kind of default builders that under the hood kind of turn a lot of things on, add a lot of middleware, things like that. One of the things that you saw in .NET 8 was the create empty builder, which basically has nothing in it at all. So if you really want to have control over exactly all the middleware that's added to your system, your API, you're really trying to make it as fast as possible, and you really have certain very specific requirements, you can do that now. You couldn't do that before. It was a lot more of a pain to try to remove things that you didn't want. So if you really want to dive into it, the Create Empty Builder gives you absolutely nothing in it and allows you to kind of build on it as you want to. Just a couple of quick slides. Most people know this, but sometimes a lot of times I speak with developers, and I'm surprised or not, just some best practices when you're building APIs. There's no reason to ever use just HTTP ever. So that's just a requirement. And then method naming is just, I've been on a lot of projects where people just kind of, I think, just randomly figured out which methods they wanted to use for certain type of things. And so just using appropriate naming is a kind of a big thing for especially larger scale projects. Consistent naming, we've seen everywhere. You know, this is kind of a rule of thumb. I think one of the biggest things I tell most of the projects I'm on is I don't really care how you do your naming convention, as long as it's consistent, and not one developer uses one thing, another developer uses another, and as long as there's some thought into it at the beginning, it typically works really well if you just actually have some sort of a naming convention. And just from an overall standpoint of the things that, like, just the quick things that I see that tend to get people on API designs. One is not using loosely coupled architecture, dependency injection, things like that. It causes so many problems when people tend to are trying to upgrade things and change things up and maintaining projects. Just creating these big monolithic applications and not taking, not modularizing everything. So you have code reuse, you have all the standard development things that you should be doing your applications. A lot of times you're not seeing that. And then for APIs, one of the biggest things that I will tell you out of the gate is that your API, typically the biggest performance issues of the API has nothing to do with the API code in itself. It is backend resources that you're trying to access that you do not handle correctly. The typical one is you've got a SQL database in the back end and your queries are horrible. And you're trying to return tons and tons of data. You've got 8 or 9 joins that are just not done correctly in the queries and things like that. So out of the bat, whenever I've gone on a project and they're saying, well, our API is really slow, typically that's the first place I look is, well, let's look at what your data access looks like and what your querying looks like. And that's typically the problem. I'll talk about some of the problems we had in some of the a little bit later in the talk, but really those are kind of the two biggest things. So let's take a look real quick at some demos. So first, our AOT, you will find things like, so one of the things that you don't get in AOT that you'll find, one of the first big headaches you'll find is they don't have JSON serialization because it's done using reflection and reflection isn't supported. So you'll see that it's most everything looks the same, but it's just you create this slim builder, which allows you to it removes a ton of different middlewares out of the gate. Other than that, code is the same except for the fact that you'll just run into things that aren't supported, and you'll get a lot of stuff. So if you're ever migrating, if you're trying to migrate an API, it's quite painful. But it doesn't support things like controllers. So if that's it has to be minimal APIs and across the board. But let's look over at so this guy here, and I'll have a link to all this code. All these code, all of this is using a TMDB, a movie database service on the back end to pull data to allow us to have some data access and do a couple things. It's free to use, so I've got that here. So this is a typical minimal API. If you look at instead of if you're where are we at? So for typically in an app, you'll have something like map controllers, and then it'll go through and it will look at all your controllers and will create maps for everything and build it behind the scenes. Here, what we have is I just built an extension, which is our map movie endpoints. And you'll see here that this is what it looks like instead of having controller. You have your different, you can do gets, puts, you can do all your methods here, define paths for it, put your code, create your code in here, which typically should just be a few lines of code, if that, which is, using dependency injection, which works really well here. So you can inject into this any of your services that are registered and offload the work outside of the endpoint so that these things are nice and clean as it could be. You can add tags, names. We'll see later where you can add quite a few different, all your authorization, everything that you can do inside your controllers, you can do here. As I said, I created this endpoint. And so instead of having in our program file, having all that code here, and especially if you're dealing with some of the APIs that we built where you've got originally, if you broke it down into controllers, and it was about 15, 20 different controllers, all having anywhere from 5 to 30 or 40 endpoints, it would get unruly in here. So by breaking it up into extensions, it allows you to do a lot of things there. One of the other cool things you can do is you can group your endpoints, and you can create these groups. And basically, instead of having to come through, like here, all our endpoints are added with a tag. All of our endpoints here, we've got our /API/movie. So we have a kind of our base being mapped here because you're adding it all individually. You can come here and you can start and you can define some of this stuff. So you can create a group and you can create the base version, the base path of this, so that when you go through and you add your endpoints, now you're just adding the rest of it. So you can really kind of start going through there and making this work a lot better for you. You can come in and you can add tags to it. You can do pretty much everything if you want to require rate limiting. You can do that. Things like that. It works really well. And this is part of being able to allow you to kind of extend things out. One of the things in .NET 9 is you no longer have native support for Swagger for building out your open API specs. You can go in and add it if you want, but there is ASP.NET has an open API application now that will do that. You can still get the Swagger UI to work. One of the biggest things you have to do is the Swagger endpoint of where your JSON is a different path than what Swagger built. So it just takes a little tweak to get Swagger to work. And you can still get it up and running. If you don't have the controllers, you do have a little bit of sometimes some of the tags. You can use tags to help group your endpoints so that if you've got movies and users and things like that, you can group that. Controllers used to do that very nicely for you because everything inside the controller would get mapped here at the controller level. So you do have access to add some of that in here. But outside of that, it will work just as you'd expect it to, and you can get data. Okay, so let's jump back over to this guy here, and let's talk about securing APIs. So the first question that I always ask people is, when should you secure your APIs? And
Always.
what's that? Do we have any answers there? No. The answer, I always get a lot of really great answers, and I mean, they're typically all right, but my answer is you always do it. I don't care if it's a free API that you have no intention of letting more than a few people use or whatever the case is. But if it's sensitive data, obviously you need to secure it. If it's corporate data, you need to secure it. If there's a million different reasons why to secure it, but then you always get the argument of, well, this is just free public use data, I don't need to secure it anyway. Some of the reasons to do it is one, just to prevent abuse of your endpoints. So if you open up a free endpoint and it's not secure at all, and you have somebody else that's using the data from your endpoint, and they're building a system around it, whether you've got some kind of local weather that you're doing, or reporting rain totals or whatever the case might be. If you don't secure it and you don't add some type of limitations around it, then if somebody else starts using that application, that API, they can create your system, overload your system, and cause people who are using or trying to use it the correct way from being able to use it. Or it could just be a simple matter where developers, sometimes we mess up and we beat on an API more than we expected to. It just also just gives you a little bit of protection from data leaks. Again, your service reputation is important because even if it's a free service, if it goes down, people are not going to use it, and you're not going to want to build a service that nobody wants to use. We do have more and more compliance regulations coming down, and so it gives you a platform to kind of build around those compliances and adjust as you need to. And then also, just bottom line, it gives you a better chance of doing logging and auditing, so you know who's using your system. It doesn't have to be a complicated way to secure your API. It doesn't have to be something, you don't have to add a ton of overload work to it. I'll show you an example here in a little bit of one of the things you can do, but it needs to have some level of security in it. And bottom line, it just allows you to future-proof it in case you decide to, if you come out of the gate and you have the API and it's free, but you're issuing tokens for people to use it, it allows you to maybe in the future possibly wanting to add, a paywall, some features behind a paywall, things like that. And if you've already got that structure in place, people are already used to it, then you're able to grow and expand your API without really people having to worry about um, going through and rechanging their code. You can just start charging people for it or charging people for new features they can add onto it without affecting people that are already using the system, things like that. So anytime you're from day one, you're doing a file new on creating an API, there should be some security around it. So security breaks up into two different things: authorization and authentication. So for your authorization, there is .NET also has some built-in modes that work really well, and you can use them in combinations. You can use just a simple authorization, meaning that if you've enabled authentication in the application and you enable authorization, as long as the user is authenticated, then they have access to it. It makes it very nice and easy to use. There's role-based authorizations, so you can define users and roles by claims, by policies. And you can use a combination of these. So, and you can define this at a top level using your minimal API structures. So you can define what the authorization is for all of your APIs, or you can go all the way down to the endpoint or a group. Like let's show you the group. You can do a group. This entire group requires this role, or these particular endpoints require these particular those roles. And then in .NET 9, you can actually, one of the things that you started seeing in 8 also is it simplifies being able to create your own custom policies. There is an unauthorized requirement data interface that you can implement, and you can create your own policies and really kind of dial down what for your specific use case. On the authentication side, there's a couple of different approaches that a lot of people take. One is just a simple API tokens. These are, as I said earlier, you don't have to have massively complex system, but just having an API token that you can issue somebody, so you know that all their calls have that token in the header. You know who's using it. You can shut down access, or based on that person, or just log, so you have stats. You can add rate limiting at the token level, so you can rate limit people based off of their tokens. So you can set it to where company A or user A has a higher rate limit than user B, and so you can handle your throttling that way. And it's really easy to just revoke them. I mean, if you're keeping if your system has a list of tokens that are acceptable, just removing that item from the list and it's gone. Or if you want to regenerate one and send it to them, or you're removing the old one and adding new tokens, it's a very easy process. And overall, that it's like one of the lowest overheads that you'll have to deal with, because you can, in most cases, you would be able to keep either the whole or or recently used list of tokens in memory. So it's a very quick process when someone makes a call to verify that token's valid, and you can allow them to access the system. JWT tokens are used a lot more these days. They're short-lived. So in most cases, a JWT token is, gives you access half hour, a day, that type of a thing. So you typically have a separate process where you might have something like an API token that originally somebody calls and uses that token to grab a JWT token, or using some other authentication level. It allows you, the great thing about JWT tokens is you can add claims inside and information inside of them when you create them. So that allows you to really make granular access, so that you're not having to do a ton of, when you issue the token, you can add all the claims permissions in that token, sign it so it's secure, and then you're not every time someone is like using if they're just using an API token to call, you're potentially having to hit a database, see what permissions they have, they don't have, and kind of change things up in this. You can embed all of it in the JWT token. And as long as it's a valid token, you know what permissions that you've already granted them. This is where the world, it hits with third-party integrations. So if you're trying to want to secure your API access on the back end of your application, do off of Google or Microsoft, you can do that. And this is the method that works for that. And it's still a very easy process if you're handling JWT tokens, whether it's going through OAuth and a third party, or if you're doing yourself, to just where if it expires, to easily just basically refresh the token and generate a new token. And there's workflows for that.
Just a question.
Yes.
You said they're revocable. That's actually not my understanding that they are. Can you touch on that?
So there's still, since it's still a token, you can still revoke tokens from the API standpoint of we've done that. We've never really had to use it, but we have a process in place to where we basically pull the tokens from being acceptable. So when we go through process the token, we're receiving the API side, we make sure that that token hasn't been revoked, and they still have permissions for it.
So it's like so you do like a blacklist.
Basically, yes.
Oh, okay. Because that's kind of one of the features of JWT is that they are standalone and
Correct.
they're secured. So you don't have to check a database. If someone sends you a JWT token, you can trust it basically.
Correct. And in most cases, that's the case. So, but if you do need to add that piece in there, then yes, a blacklist or something along those lines would work.
Okay. Thank you.
Yep. Certificates start getting a little bit more complex. They are definitely stronger. There's a little more stronger security around it. There is definitely more to work with to get certificates to work from an API standpoint. They, depending on your industry, there are different regulatory requirements that make certificate communications required. You see it, some of the medical, some of our medical stuff that we've dealt with, we've had to have that in cases. You'll see that in banking quite a bit. It does basically, it goes along the lines of, once you've issued that certificate from your main from your root to the client, unless you do something like blacklisting it as well, they're trusted with that. We see this a lot in hardware devices. So our hardware devices that we send out to the field, they all handle their communications, our main APIs through certificates. They all get, when they get baked and image, they all get their own certificates. And so we know exactly who the device is. It makes that process a lot easier. We can just basically, from our endpoint, say, hey, if this is a valid certificate coming from this device, then good. It does get tricky when you start having to worry about stolen devices and things like that. But it is a very secure form of authentication, and it works really well. All right, so let's do this. Where's this guy? So I have an example here. This is adding, so looking at our authorization. So when you're adding authorization to your APIs, this first policy I'm adding is using just some of the baked in things. So this particular policy, if we're going to use this, the user has to be authenticated and have an admin role assigned to it. And then if you look at the claims attached to the user, it needs to have an OR claim that's with a value of Acme. So this allows us to basically really start, and both of these have to be met for this policy to be approved. So you can go through and build this out as complex as you needed to. As I also said, there is the ability to create your custom ones. So this is a minimum age requirement one. And so this is a real simple, you define what that minimum age is. And so let's see, there's a requirement. Where is my site? And then you have to create a handler, an authorization handler that handles that requirement, that does the work. So what this does, and for ours, is we take, when we create the requirement, we add a minimum age in here. Then when we're processing when we're processing the call, we look to see if there's a claim that has of age, and it makes sure that that value is actually greater than or equal to the minimum age. So this gives us a way of creating a custom endpoint to where we only allow some people after a certain age. So once you define these policies in your system, adding them is a pretty simple, straightforward process. Again, if we look at our group builders, what I did was, instead of having everything just done one at a time, I went through and created a group where I added required authorization and said they need to be at least 21. So I'll go ahead and show you this, then we'll look a little more into this, get that going. So in our endpoints, let's see this up and I'll show it. So what we're going to do here is we're going to create our token, and we'll just say 16. What this does is this endpoint, I'll show you this endpoint, creates a token for us. We're going to come in here, we're going to authorize with this token. And then we're going to come over here to our movies, and we'll just grab the first page. And we're going to get kicked off with a 403 that we don't have access to it. If we come back and do this guy, let's create a one with 22, copy him. Yeah, and we'll authorize with this new guy. Come back and make the same call, and we get data. So what's happening under the scenes here, behind the scenes here, is first our token endpoint. What we're doing is when we call that get, I'm just creating a JWT token, just a very simple one where it's got a couple of claims. I'm adding an ID to it, but then adding our age that we pass in there, creating the ticket, the token, and returning it. So that's what's getting returned. Then in our application, we have come through here, and a very simple, again, since we're doing this on our, from scratch, on our events, when we validated that it's a valid token, we're adding a little bit extra work in here to check to make sure that there is an ID that we have in there, and that's not equal to null. And then we are checking to make sure the token is valid. And then if the token is valid, then we return success or not. So then we could actually, we can come here on our token service, and we could remove tokens and basically take and blacklist that particular item out of here. So this gives you just a simple, straightforward way of creating a token-based authentication, and also creating custom authorization for it as well. And then, as I said, once you in your services, adding your authentication and adding your authorizations, fairly straightforward here. And then enabling them is just like it is inside of a controller-based API. You just you use the authentication, you use the authorization. So we can, and then you can, we left our token-based endpoint not requiring authorization, so we get access to it. So just our movies ones has this filter on it, and you can mix and match however you need to completely secure your applications. Let's see. All right, and it is okay. So I'm going to go through this a little bit faster because I'm going to run out of time completely. All right. So scaling performance. So I just want to talk through some things for scaling and performance. One, everything should be stateless unless you need state for any particular reason. And if you do need state, typically it is an offloaded type of a thing and you need to track that on a database. And then one of the reasons why your API call should be stateless is because for scaling, if you're running this in say Azure or AWS and you want to scale out your instances, the moment you do that, your any kind of state, if you're not handling it on the back end, like tracking it in like a Redis cache or a database, goes away because each call could be from one instance to the next. And so your state no longer works. The I said the ways to get around this, if you need to track state, things we've done before are tracking in some data store, whether it's Azure Tables or a nice, quick, easy access SQL database, Redis cache, things like that. If you do have processes that kind of step through things, another is durable functions in Azure is a great way to take data and move data along a track based off of, we've received the original data. Now we've received the next phase, what we're looking for and things like that, and allow you to kind of move the state along that way. But keeping your API stateless is at all costs is one of the key things here. A couple minor things, async programming keeps you from hanging up your application. You can enable compression with a simple middleware call inside of it, your startup, and that will help compress the data that you're sending across. So it will speed up things from a delivery standpoint. The serialization, if you, the new system.text.json, which has been out for a few versions now, is right at 2 times faster than Newtonsoft. That's a huge performance when you're dealing with tons of data calls. And the other aspect of this, whether either one you're using, is to only return the properties that are needed. I've seen a ton of different applications where you need an ID and maybe a name, but yet you're getting the entire data objects back, and it's bulk that is going across the wire. It's less secure because it's not needing to go through, and it takes longer and it dings your performance. Caching is a big thing and to help performance, and there's several different ways you can do it. And there's a lot of cases where caching just makes sense. There are some that doesn't. And so you have to, if you're going to be looking at using caching, you definitely have to take the time to map out a solid approach. But there's several different kinds that you can use. So response caching is basically, it's using a cache control header. You can add that to a web call, and then for the most part, most of the browsers will honor that. So unless the user is forcing them to redo it, so you can send a cache control header back, and if you're running a spa or something like that, the browser most likely will not actually make another call until it expires, just so it never actually leaves the browser. It's a nice little way to do it. It's very easy to implement. You can handle that at the controller or at the endpoint level when you create it. The problem is you can't validate it. Once you've done that, it's out of your hands. So for things like a list of states, it makes perfect sense because that's not changing. Your user permissions, not necessarily the best way to go about it. In-memory caching is another way that works really well for just performance and speed Again, you will have duplication of this if you're scaling out. So that needs to be considered. And then, how much you're using needs to be considered. You can't cache. The more stuff you try to cache, the slower your API is going to be. .NET does have the caching services do actually have limits to where if you start maxing out memory, it will blow things away out of cache. But it is important to realize that once you're caching in memory, you do have to manage that. It works really great for speed of things. As I said, like if you are in our token example, if you've pulled a token and you're wanting to keep that in memory that it's valid, you can just keep that going, and then keep it in memory to keep having to make a database call each time. If you and you can adjust your caching so where it's not cached forever. You can cache it for 30 minutes or 15 minutes. You can cache it per item that you're caching. This works really well for speeding things up and just pulling work off of those database calls, those backend data calls, because at the end of the day, that's where a lot of the slowdowns happen. And so this is where this really improves it. If you want to be scalable, then distributed caches are the way to go. Redis is a very popular one. We use it a lot. It's very performant. And again, if you're scaling out, or if you're using multiple different APIs that you're wanting to share a Redis cache from different systems, it works really great. Again, you still have all the same kind of controls where you can define how long a piece of data is going to be cached for before it rolls off, or kind of first in, last out type of a process. There's a lot of different controls. It's pretty much all the same as you have in memory. There are costs to it because you've got another service, obviously, you're dealing with, and it can be very difficult to troubleshoot. One of the things, it's very easy when people are I see it happens a lot in some of our teams where we're running Redis cache for our dev environment, and people are rerunning things locally, forgetting to disable the Redis cache, and they can't figure out why their changes are not working because the data's been cached, and they get stomped. So it can be a little bit troublesome. Redis itself works really well. We did have to add some wrappers around our Redis cache calls because Redis hardly ever goes down, but when it does, it just doesn't return. And it's a very weird thing where our system would just completely hang because it was making a Redis call that would just never return. So we had to actually do timeout wrappers around that to make sure that we protected against that. We learned that one the hard way in production, but overall, this is a great enterprise level solution. Versioning APIs is very important. And again, with securing your APIs, I would suggest from day one, file.new, that you look at versioning, because one, it's easier to start off with versioning, even if you never have to do a V2 or a V1.1 or whatever. It does, just having it there, it gives you that room to grow. It allows your API to grow and change and morph without breaking people who are already using it. And it's a very efficient way to basically add longevity to your APIs. Health checks. If you are not using health checks, it's a great way to just to make sure everything's going well in your application, to be able to get quick updates on your APIs. If you're using things like Front Door, it's got baked in polling that will poll your health API, your endpoint, to make sure that your application is healthy. Things that which works great for in case of Front Door, to where if you have one endpoint go down for whatever reason, it can't connect to a resource or something like that, then your load balancers can just bypass that and work on the ones that are currently working. This works really good also for things like rollouts. We've used this before to where instead of really having to mess with Front Door much on its configuration, we'll just flip a switch on an API and let it show it's unhealthy front door, ignore it, and then it'll give us a chance to roll in updates, re-enable it when it's ready to go. There's built-in support for it, and there's a lot of extensions that you can do, and I'll show you how to build a custom one. But this is great for not just, hey, can I hit my API, but can your API hit Redis? Can your API hit SQL Server? Can it hit the backend storage containers? Can it do all the things it needs to do to function correctly? And I said you can create custom ones. So there are, I'll just show you this in code because we're going to run out of time. Rate limiting. All right. So rate limiting is kind of cool. It is baked into the middleware. You've got different algorithms that you can use, and you can mix and match these just like you can for your authorization. You can limit like a fixed window saying a user can only hit this endpoint 5 times in a minute. And that's just from the first time they make the call, they can only make 4 more calls inside that minute. You can use a sliding window to basically say, okay, just it isolates the amount of time that bucket. So that way it's not they've been slowly hitting it, but then all of a sudden they hit it a lot. You can do it that way. You can create token buckets to where a certain token can only have access to so many concurrencies. And I'll show you how you can chain these. You can also apply them. You can create filtered conditions, and you can apply it per endpoint or the entire system. So let's do this. All right. So I wanted to look at versioning. Versioning is pretty simple and straightforward using your minimal APIs. For versioning to work, you have to create a new version set to where you define what versions are supported. You can do this for each endpoint and add it in there, but it works best, again, if you're just using your groups. So what I did here was I created version 1 and a version 2. I went ahead and for the root path for these guys, I just went ahead and add my API version in here. So the naming is works. And then if you dig into here, the only difference here is when you defining your endpoint, you just map it to an API version. So I just group these to version 1 and version 2. And then what I ended up doing was creating for version 1, the calls are just like everyone else. For version 2, I created an extended one so that I could get some more data back in this guy. Let's see. And do we have a hard stop at 1?
We'll let folks drop off, Tony.
Okay.
Because
it's not a hard stop, but probably within, I would say, 5 minutes.
Okay.
Yeah.
I'm rolling this.
Yeah. So feel free to drop off if you need to and stick around.
Yep.
Okay. So I'll roll this real quick, and then I can stick around for questions, and we'll do it that way. And you can define Swagger to handle your different versions. So things like this guy here. Our results, we're just getting the title and release dates for our movies. And then if we come over to our V2, we make the same call. We'll see that now we're getting more data. So this is a great way to extend your APIs. And tell you what, let me see if I got anything else to talk about real quick. And then I can show code, or we can talk code and answer questions. So understanding, okay. So again, I've already talked about a lot of this. Your APIs, when you're looking at building APIs, typically your API is not the problem, it's somewhere else. And one of the things when you look at architecture, the biggest things is where you can offload work from your API, so that when someone's making it and calling it endpoint, they're not sitting around waiting. This happen, works great when you have resources that have limited bandwidth. Things like Cosmos. There's depending on how much you're spending on your Cosmos, there's only so much you can beat on Cosmos before it starts throwing 429 errors. And this gives you a chance to control how much you're beating on it. Whereas if you just had an endpoint that was just writing data straight to Cosmos, then you can easily overwhelm it and then cause API issues. So we look at offloading the work, and since we're over, basically, I'll show you here in a second. There's a background service inside of ASP.NET that you can create that you can run kind of a time-based events or, a time jobs or event-based jobs. It's got the pros on it. It's simple. You can build it inside your API. You're not needing, extra services. The problem with it doesn't scale well all the time, depending on your use cases. And if you handle things correctly, then you have a lot of stuff that you're going to have to just build and write code on your own. So it can be a little overwhelming. I'll show you an example of it. What we typically do, and what we have found that works, and this will show this better, is what we've done that works really well, just to kind of jump into Azure world a little bit, is we've kind of created an offloaded systems that if we have something that's going to take a lot of work to do, like report generation, we will have an API. Someone will make the request. We'll take that request and we'll just throw it on a service bus, an Azure service bus, which is basically a queue. And then we have a function that is triggered off of, you can have a service bus triggered function. So when items get added to it, that function will fire off. It will create everything, create the reports, create the PDFs, adds it to a storage account, and then kicks off an email and says, hey, your report's ready. So this means it pulls it from our API. We're not having to work on it. We can streamline our functions to where we're only running functions at a very limited process amount. So we're not beating on our databases and causing other issues, because this is kind of a low priority issue for us. And so this is the type of things that we start looking at when we start talking architecture for our endpoints. So with that, and I'll be glad to talk about that some more for anybody who sticks around. I did just want to give my top little 3 things here. When you're building APIs, the better that you can understand the entire process from the beginning, the better you can design these things. And you need to, as I said, you need to understand where your limitations are, your Cosmos limitations, your SQL limitations, your storage limitations, whatever you're using in the backend outside the API. It's important to know that to build these things correctly. Security from the beginning, and performance, it's about testing. I can't tell you when the amount of, with some of these heavy loads that we've dealt with and some of these APIs, stuff will break that you'll never consider breaking until you put it under load. So if you're building anything that you think might have some type of a load testing and performance testing is important, because there will be just randomness that will break on you that you'll never expect. So that's kind of my top big 3 takeaways here. Open to the questions. These samples are on GitHub. I didn't mean to do that. Hold on a second. Let me come over here and grab this, and I can put that in the chat if I can find the chat. Where's my chat?
Hey, Tony, while you're
That's
looking real quick, what platform are you using to do load testing?
Depends. There was a JavaScript platform, and I cannot remember the name of it, that we used, and we just ran it in VMs that worked really well. We tried a couple of different things that we didn't like. So we've got our own platforms now that we do our load testing with, so that we can do multi-step and can kind of step through our entire process. Oh, there it is. So we spent a while, a couple of years ago, looking for something suitable, and we just never really came across anything. So, unfortunately.
Okay. Any other questions?
And
Liked all the questions you got in the middle of the talk. That was awesome.
Yeah. That works. It's always more fun when that happens.
I have a question. So initially you talked about AOT. So has that been solved where you can use AOT with EF yet? Because I ran into issue with that some
No,
things in EF did not support AOT.
and reflection inside of EF is going to break that.
Yeah.
That's and that's a core thing that AOT is not going to get around, from my understanding, is reflection. So yes, so EF will not work. It's amazing what doesn't work once you take reflection out of .NET. Now, if they change that at some point, which I don't understand why they wouldn't be able to, that would be different. But I have not heard anything that they're going to change that anytime soon.
Hey, Tony. You mentioned a couple of ways for authorization. Can you combine the authorization methods or not?
Yes. So from authorization, you can come through and right here. So like here for our authorization, like this guy here, it's adding a role and a claim as a requirement. And then we've got our custom at least 21. So we can come down here where I'd said that when we require authorization, we need to add at least 21. We can come in here and add that also. So on top of it, gives you even more fine control. So you're not having to create a ton of different policy combinations. You can create multiple policies and then just come through here and say, hey, these are the policies we want for this particular endpoint or group of endpoints. So it gives you different levels of way you can actually combine them.
Okay.
So you mentioned a couple different ways of doing caching, in memory caching and distributed cache. I haven't actually worked too much with like a Redis distributed cache, but I've worked in a system where it's essentially a distributed in-memory cache, and that there's a queue that messages are pushed to, or really I guess it's a topic, and then each instance of the API is subscribed to that topic, and it receives those messages and updates the in-memory cache for each of those APIs based on those messages. So I'm wondering if is that kind of a typical approach, and does it have a performance benefit over a distributed cache or a cost saving benefit over a distributed cache typically, or would it really be recommended to go with just like a Redis service based distributed cache instead of that for simplicity's sake?
That obviously gets, if you're adding that, so you're just going through a service bus topic is how it was going. How it was built out. Yeah. So, for me, whatever works. As I said, there's been some issues with Redis cache. The benefit of a Redis cache is that you can start and stop it, and you can flush it completely, and everything for everyone's using it goes away. Whereas in your solution, you would have to also create a flush message that gets dumped out that topic, and so you'd have to basically go through and implement a lot of that stuff. Now that also allows you to give you more control over things, right? So that you can say, hey, if your API, 1, go ahead and flush your cache. If you are 2, leave it. I mean, so that gives you actually some fine-tuned control that you could use. So it just really depends on your use case. And like most things in .NET most things, it just depends on how much stuff you want to bake in yourself and versus using something that's already there.
And the nice benefit of Redis is also cold start. So in your situation, let's say you upgrade all your, server, all your servers restart, so you lose all your in-memory cache. So the first request, they will have to populate the in-memory cache unless you build something besides that, versus Redis, unless your Redis service goes down, but let's say you're using something from Azure, it doesn't really go down, right? Then it's already populated. So once your service comes up, you don't have a cold start issue. It's already, the data is already in the cache.
Yep.
Gotcha. Yeah, that's really helpful. I was kind of throwing that out there because I'm mostly new to those sorts of systems with the architecture of caching systems in general. And I've kind of stepped into this system that was all put there before I got here. So I'm just kind of looking for validation on if that's a sensible way to go about it, or if it's, tech debt item, but that helps to understand that a little bit more.
And I want to add, I mean, Redis, I use Redis in several projects and it works really well. And another nice feature of Redis that actually has a simple pub sub feature in it as well. So if you don't already have like a service bus in your architecture, you can actually use it to push messages through that will then be distributed among your different consumers. Let's say you have multiple web servers and you want to push out like a whatever a message may be, or maybe like a trigger to run a background process or something like that, then you can actually use Redis for that as well as a memory cache. So it has some additional nice features.
Yep. It's a nice little system, and it works great when it works. And we've only literally had, I think, 3 times in the last several years it's hung on us. So the big other thing to remember about caching, and I don't think I said it, is if you're going to implement caching, you have to make sure you manage that cache well. So if you are caching an item, that if you update the item in the database, anywhere that you can update the item on the back end, that you're updating that cache. Or what really gets people is sometimes you'll have an item cached a couple of places, like 1, the individual item, or 2, in a short list somewhere. So you also have to keep track of, okay, I updated this item, so I've got to invalidate the cache for the item plus the list that it's involved part of. So it definitely you have to make sure you're mapping everything out correctly, or it'll get you.
Or if you patch something manually in a database because you found some issue and then you're fixing the data and you don't flush the cache.
True.
That has bit me several times.
All right. Well, I think we're going to wrap up here. Tony, really appreciate your time. Great stuff. Daniel, anything else before we close?
I don't think so. Just DevOps Days Austin and the in-person meetup.
Yeah, in-person meetup. There's a link in the chat, or just come to the meetup page and subscribe. We'll get more info on where it's going to be in the next couple of weeks. But appreciate everyone joining. Thank you.
All right. Appreciate it.
Thanks, Tony.